Hello students, welcome you in the video number 15. Here we were discussing about the oxidation states. Now after the zero oxidation states, that is in carbonyls, that is nickel carbonyl, there is one interesting fact is that usually transition elements usually transition metal ions uh, in their lower oxidation states in lower oxidation states are good reducing agent. Good reducing agents, and those of in higher oxidation states are good oxidizing good oxidizing mm, agents. Okay, good oxidizing agents. Now what does this mean? That reducing agent means self oxidation. If they are in low oxidation state, so they can further apply for the higher oxidation. That's why they are good reducing agent. Okay, similarly oxidizing agent means self reduction. Okay, now they are already in their higher oxidation state, so they further they cannot oxidize further, so they have only one direction, that is self reduction. That's why they are uh, good oxidizing agent. Let's see some examples. And now here scandium 2 plus, titanium 2 plus, vanadium 2 plus, Fe 2 plus, and cobalt 2 plus, they all are good reducing agent. They all are they all make it correct. They all are reducing agents. And similarly, if you see chromium 6 plus, manganese 7 plus, and manganese 6 plus, etc., they are good oxidizing agents. Okay, now if we see their relative stabilities, uh, if we see their relative stabilities, if we see their relative stabilities of various oxidation state with respect to each other, then we will find that if any compound is having three not three, having D0, D5 and D10 electronic configuration, any ion or any element having this configuration are comparatively more stable than the other. Now let's have some example of this. For example, titanium 4 plus is more stable than titanium 3 plus. Okay, similarly manganese 2 plus is more stable than manganese 3 plus. Now if you see why, in titanium 4 plus it is 3D0, in titanium in titanium 4 plus it is 3D0, and in titanium 3 plus it is 3D1. Now if you see which is more stable, 3D0 of course. Similarly here in Mn2 plus it is having 3D5, and then in Mn3 plus it would have been 3D4. So 3D5 is exactly half filled, it is more stable. That's why manganese 2 plus is more stable than manganese 3 plus. So in such a way you can compare. And similarly you will see there they're having highest oxidation state along with the compounds made up with oxygen, etc. And in that set they behave as good oxidizing agent. So for example, if you see chromium CrO4 2 minus, similarly if you see manganese O4 1 minus, now they are strong oxidizing agent. Now what does that mean and why this is so? So if we elaborate that, oxidizing agent means self reduction. Okay, now why they have this tendency? Because in MnO4 minus manganese is having +7 oxygen set. In CrO4 2 minus chromium, that is chromate ion, the chromium is having uh, +6 oxygen set. So for chromium it is highest oxygen set, for manganese +7 is highest oxygen set. So in these states they cannot proceed further, they have to come back. It means they have to reduce themselves. That's why they are very good strong oxidizing agents. So oxygen with oxygen their maximum oxygen state can be stabilized. So they form the compounds in maximum oxygen state with elements like oxygen. So we'll see now next property of the transition elements, and that will be in the next video. So wait for that. Bye, see you soon.